In this video, we're going to be learning about lines of symmetry and reflections. So let's start off with what is a line of symmetry? Well, a line of symmetry is the imaginary line where you could fold an image and that where both halves will be identical and match exactly. Well, now we looked at that word image. What is an image? An image is a duplicate or another reproduction of an object that may have been enlarged, reduced, rotated, translated, or reflected. So in this lesson, we are looking at reflections and lines of symmetry. So let's start with this first example. Where is my line of symmetry? And how do I know where it is? Well, my line of symmetry here must divide it in half perfectly. So that means if I take a ruler, I'm going to be able to measure every point across. So if I look at E is just over 4.5 centimeters across. Then I take my ruler and I'm going to measure B. B is just over 4.5 centimeters across. Let's look at D. D is 2 centimeters. C is 2 centimeters. And if I follow every point on this graph here, or on this image, everything will be the same on the AED side as it is on the ABC side. Everything's going to be equidistant from my line of symmetry. That's how I know it's a line of symmetry. I could draw possibly a couple more here, but they may not work. So let's try if I went this way over here. Well, now I'm looking at this. I'm always going at an angle. So it's not going to be quite perfect no matter what I do. I don't think D is as far as A. So let's measure with my ruler here and measure certain distances. So we have D here is approximately 4. And if I go straight across, these two here should be straight across from each other. And I have a total distance of 8.5. Well, that's 4.5, so that does work. But now, let's try another point. Let's try, this B. This line here is a lot different. So if I'm going to highlight this line here is a lot different, well then, this line here. There is a different distance between them. This one is longer than this line. So therefore, it doesn't quite divide it in half. And my only line of symmetry is my main line right here. This is going to be my only line of symmetry. I could try it from the other angles as well, but none of them are going to work except for that one. So in these examples, it wants us to find the lines and identify the lines of symmetry, and we're going to explain how we know they are lines of symmetry. So let's first look at a diagonal line. If I'd had a diagonal line that went across like this, somehow, would this be a line of symmetry? Well, if I measure this point and this point are 1, that works. Here we have 1, 2, 3 away, whereas here we have 1, 2 away. So that's not going to work now. We have different points that are different distances. Well, what would happen if I move this line here? Well, that's obviously not going to work. Now, what if I changed my angle a bit? Well, now, I don't think that's going to work as well. If we went from here and we changed my angle to there, that may work, but I don't think it's going to work overall. So let's try this out here. I have, once again, 1, 1. 1, 2, and then here I'm going to have not quite 1, not quite 2. It's not going to quite work. So the diagonals don't work. Let's try a horizontal now. So I'm going to move this horizontally and try and find in the middle there. Well, that's not quite the middle, so I have to move down here. So now, let's look at this. We have 1, 2, 1, 2. Good. Everything's 2. 1, 2. And then a half. This is a half and 1. So this one doesn't work as well. So we don't have any diagonals or horizontal. Let's try my vertical for this now. So now I'm going to try my vertical and extend my line. Let's see if this works for the vertical. So here, I put it there. I want to try this out. So I have 1, 1, and then it goes over to 2, 2. That's good. Here, 1, 2, there we go. 1, 2. That matches. 1 and a half, half, and 1. Good. So if I'm looking at this, I keep on going across, I'm seeing that this works. So this one here only has one line of symmetry. Or I can measure it with my ruler, each part, and make sure each part is equal distance apart. Now let's try number 2. So let's look at my second tessellation. I'm going to make a line again. And let's first try my horizontal. So I'm going like this here. I made a horizontal line. Now let's see if every point on either side of the line is equal distance. So we go perpendicular to the line. I have 1 point, perpendicular to the line, another point. They're equal. My next one, 1, 1. They're equal. Here we have half and 1, 1 and a half. Let's move this one, 1 and a half. These ones are equal. I keep on going like this, and I find out that all of these are equal distance. So here we have one line of symmetry. Let's try make another line of symmetry. Let's try this horizontal line. Once again, if I test it and measure out the distances between each one, I could use a ruler, 1, 1, or I could just, if we have a grid like this, it's a bit easier. 1, 1. Here we have half and 1, half and 1, and this one is going. So this will work perfectly. So then right here, this works perfect. This has right now 2 lines of symmetry. Let's see if we could find another. If I go on the horizontal, once I go to this line right here, everything's going to be equal distance. We have everything is equal distance, and we can measure it and check. And I can make one more line, and that's the vertical right here, and everything's equal distance. So altogether, I have a total of 1, 2, 3, and 4 lines. So we have 4 lines of symmetry. So my next example wants us to find a reflection about the line x equals 6. So first we're going to have to draw a line where x is equal to 6. So I look at my x-axis, and it's right here, and we want where x is equal to 6. So I go from 6 and I draw straight up on my x-axis because x is equal to 6. Now I want to reflect this image here perfectly. So everything must be equal distance. So there's that red there for my image. And then we have one that is 1, 2, 3, 4 away. So I'm going to move 1, 2, 3, 4. And then we have to connect those dots. And there is my image. Everything must be equal distance perpendicular from the line. Okay, let's try my next one. My next one says a reflection on the line y is equal to x. So let's make my first line here where y is equal to x. So let's make a table to help us solve this. We're going to have y and x. So when y is equal to 1, x is equal to 1. When y is equal to 2, x must be equal to 2. When y is equal to 3, x is equal to 3. I think you're seeing the point here. So whatever the y value is, the x value must be as well, because y is equal to the x value and x is equal to the y value. So let's draw a line for that. So we're going to draw a line right here like this. So once again, you look at this. When x is equal to 1, y is equal to 1. When x is equal to 2, y is equal to 2, and so on. Now we want to reflect this image on that line. So everything must be equal distant away. So I'm going to actually, for this one here, draw my point. So here's going to be my first point. It's on the line. Now I'm going to look at this point here, and it's exactly half a distance away. So I put it away. Remember, we're always going to be going perpendicular. So remember, we're always going perpendicular. Every point must be perpendicular away from my segment. So my next point here is 1 away, so I go a whole distance of 1 away. Then I have one that's 1.5 away, so I have to go half and then 1 away. Then my last point here is 1, 2 away. So I'm going to go 1, 2 diagonal squares away. Now, I look at this point here, it is 1.5. So I keep on following this line from right here. I'm going to go 1.5. From this point here, it's a total 1. So from here, 1. Now, let's draw this out. Connect my dots. And my image is going to look like that. In this example, we have this red shape here in this diagram, and we want to figure out which colors are reflections of it. So we're going to have to try and find lines of reflections for each shape here. So let's first look at my green shape. So I'm going to draw my line for my green shape right here. That looks about halfway through. Now remember, everything must be perpendicular from the line the same distance. So I look at this triangle, it's 1 away. This triangle is 1 away. Let's look at this tip of the square, 1, 2 away. The tip of this green square, 2 away. Let's look at the tip of this triangle here is 3. Tip of that triangle is 3. So this looks perfect. So the green one is a reflection of the red. Now let's try another one. Let's try the purple one. Well, let's look here. Everything must be equal distance apart. So I go with this here, and we see all of these lines here as they're medium between them. So let's look at this. These 2 points here, they are a total of 1, 2, 3 apart. So 1.5 works. Let's look from this corner to this corner. We have 1, 2, 3. So 1.5 would work there. So I might want to make a line that's 1.5 away from the red and at a diagonal. So I'm going to make my line, and it's going to be at a diagonal, something like that, and I want it 1.5 away. So now that I have my diagonal, I'm just going to double check and measure everything. So if I look at this corner of the red, it is 1, 2.5. This corner of the purple is 1, 2.5. So that works too. So the purple is a reflection of the red. Now let's try my blue. So for my blue, I'm just going to draw where I think my line of reflection is, and it should be somewhere around here. Now let's measure and check. So everything here, this point is 1, 2 away. Well, this point here is 1, 2 away. 1 away, 1 away. So the blue is also a reflection. Now let's try my last one, which is the tan one. So my tan, if we have a reflection, it has to be somewhere in between. So I'm going to try a reflection like right here. But now the problem is, let's have a look at this here. This red point is half away, whereas the point of the next triangle over here that's perpendicular, that is quite a bit farther away. That's 2.5 away. So these are not equidistant in a perpendicular line. This here is 1.5 away. Well, that's 1.5 away, so that works. But this point here is 2.5 away, where this one's only half away. So the brown is not a reflection of the red, or the tan is not a reflection of the red. So what do we notice here? Anytime we have a reflection, something else happens. The orientation changes. So if I look at this, this is going this way, whereas this one here is going the exact opposite direction. Once again, this is going there, this orientation is switched. So when we have a reflection, my orientation also switches. So think of in the mirror. When you look in a mirror, you see your reflection. Your left hand becomes your right hand in the mirror, and your right hand becomes the left hand. So your orientation switched when there is a reflection.